Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to all of you. And yes, everybody in the chat box, do let me know. Yes, students. Okay, so today guys we'll be starting with, actually we'll be doing stability of intermediates, right, which is based on resonance, hyperconjugation, aromaticity, back bonding, all these effects that we have done till now. We will use that in calculating stability of the intermediates, right? Okay, so before that let me see that how many of you have done the homework. So Rama Raju has done the homework, then Swarna has done the homework. Very good, very good. What about the other students? When you will start doing the homework, huh? When the time will come? So, before that, let me tell you what was the correct answer here. So, the correct answer is A. Why? Because this is 1, 2, 3, 4, 5, 6. This is 6 pi electrons. So, this is aromatic in nature. This we know is non-aromatic. This is 8 aniline. This is 8 aniline, which is non-aromatic in nature, right? Then this P is 4 pi electrons, which is anti-aromatic in nature. So we know that Q, then you have R, then you have P. So answer will be A is the correct answer here. Now, before moving forward, what we are going to see that this is MDSAT scholarship program, guys, right? Just how many? 15 days are left for it, right? And the registration dates are going to close soon. So register yourself. Registration is totally free of cost. And here, ma'am, what we will get here, right? First thing is you don't have to pay a penny here, right? Just give the test, right, based on your rank. If you are among 2.5 lakh students, right, then you will get 100% scholarship on all the Vedantu courses. 150 crore worth of scholarship you will get, 2 crore worth of prizes, cash, like you will get iPhone, iPads, all these things you will get, plus you will get one-on-one mentorship, counseling also with the teachers, right, regarding your path of this, whether you are in like in 11th class, in 12th class, or a dropper. Based on that, personal guidance will be provided to you, right? So all these things are there. All you need to do is give the test. The dates are 4th, 5th, 11th and 12th of October, right? Okay, everybody, understood? Yes. Now let us start doing stability of intermediates, right? So for that you should know what is the priority order of stability of intermediates. When you see the priority order, it is BARHI, Barhi. You just have to remember every single question will be done based on BARHI, right? Where B is back bonding, B is, or I would say it here, back bonding, right? Back bonding, these all factors we have discussed. A is aromaticity, aromaticity. Then you will see resonance, resonance. Then you will see hyperconjugation, hyperconjugation. And the last factor is inductive effect. Last factor is inductive effect. One by one we have seen all of them, right? PDF of resonance session, was it not uploaded? Okay, I'll see. I'll just ask the team if it was uploaded or not. And if it was not uploaded, it will be done by tomorrow, right? Okay, yes. Okay, due to backlog in 11th, but I am managing to study because of you. Thank you, ma'am. Most welcome, Pranavi. Most welcome, right? Okay. Now, is this lecture enough that you cover all the topics? No, I am not going to cover all these topics here. This I have done specially in resonance, back bonding in resonance we have discussed in the lecture number 2. Aromaticity and hyperconjugation we discussed this yesterday. Inductive effect was the first lecture that we discussed, right? Okay, these I can't tell you just like that. This is inductive hyperconjugation. I have taken proper lectures on that, right? And if you have no idea about these effects, then don't watch this lecture. I'll be very clear with you, right? Firstly, go and watch the lecture of 3 lectures you have for all these electron displacement effect. Watch these, only then come back to this lecture, right? Otherwise, it will be of no use. You will get confused in throughout the lecture, right? Okay, organic is like you go from first step, then second step, then third, then fourth. It is a stepwise thing, right? So that's why I have covered all of this before. Now we are going to see the application part of it, how to find the stability of intermediate, the question that is asked in the exam, right? So the question that is asked from GOC is stability of intermediate, acidity and basicity. Stability of intermediates we'll do today, right? So whenever you see any question, first thing always what you will do, so firstly we are going to write for carbocation. The first thing that we are going to do always is going to be writing BARHI, okay, right, BARHI. In this, firstly, see whether back bonding you can see anywhere. So what do you mean by Barhi? Firstly, you will see whether in any case back bonding is applied. First, you will try to answer it according to back bonding. Then you will try to answer it according to aromaticity, then resonance and so on, right? So with examples, you will be able to understand this, right? So first is there any situation where back bonding is applied? No. I can't see, I can only see electron deficient. I can't see any electron rich species which can donate the electrons also. So back bonding is definitely not there. Resonance definitely not there. Aromaticity firstly I have to tell. Aromaticity is also not there. No one is cyclic here. So not possible. Resonance not there. For resonance you need to have double bond, single bond, p orbital or alternate double single bonds. That is also not there. So this will also be cancelled. Hyperconjugation is there, right? So here you have CH3, here you have CH3, here you have CH2, here you have CH, right? This is CH3, this is CH2, right? So if you see, this is the mean, this is alpha, this is alpha, this is alpha, 3, 4, 5, 6, 7, 8, 8 alpha hydrogen, that means 8 hyperconjugating structures. Here you have this as alpha, that means 4 hyperconjugating structures, and here only this is alpha, that means here you have 2 hyperconjugating structures, right? So we can say the order is going to be A, then B, then C is going to be the correct order here, right? Okay, understood? A, B, C is going to be the correct order. That is based on hyperconjugation. Some students they say, ma'am, it is based on inductive. No, inductive is after hyperconjugation. If I am able to answer it based on hyperconjugation, I will not look for inductive effect here. If you can answer this based on hyperconjugation, stop there. Don't look for inductive effect after that, right? Now, next is this compound, that is, this is A and this is B. Now again write Barhi, B-A-R-H-I, okay. Now in this case, you will see that back bonding, is it possible? Electron deficient you have. Do you have electron rich? Oxygen, if you see, oxygen family has 2 lone pairs, right? And that's how you will know that yes, back bonding is definitely possible. But the problem is back bonding is possible in both the cases. Now we have to understand that where the back bonding will be more, right? So let's understand that concept, that where the back bonding will be more. Just give me a second. Let's see that where the back bonding is going to be more. So when you go along the period or you go down the group, right? Along the period or down the group, extent of electron donation decreases, right? Why so? Let's understand that, right? So along the period, let's say you have nitrogen, oxygen, fluorine, this is carbon, let's say this is along the period, right? Now if you see along the period what is happening, electron negativity is increasing. So this fluorine is like, I will not donate the electron because I am highly electronegative. Carbonyl is like, I am not electronegative, so I can donate the electron, right? So that is why along the period, the extent of donation to give the electron decreases. Fluorine is highly electronegative, it would not want to donate the electrons, right? And down the group, ma'am, electronegativity is decreasing. Down the group, it's not because of electronegativity. Down the group, it is because of overlapping, right? If you see this here, let's see. You have fluorine, chlorine, bromine, iodine, or anything you have. Let's say you have oxygen, sulfur, selenium, polonium. Okay. Now see, in this case, down the group, what is happening? This is in 2p. This is in 3p, this is in 4p, this is in 5p, this is in 6p, right? And if you see, in this case, carbocation is in 2p, right? So that is why when you see down the group what is happening, 2p overlapping will be good as compared to 2p 3p, as compared to 2p 4p, as compared to 2p 5p. So the overlapping goes this way. 2p is maximum, then you have 2p 3p, then you have 2p 4p, then you have 2p 5p, right? And so on, it decreases down the group, right? So it's like same members. If you are in class 12th and someone else is also in class 12th, you will have more things in common. You are in non-medical, you are doing PCM, your friend is also doing PCM, you will have more things in common. Rather than someone who is in arts or commerce, you will have less topics to discuss on, right? Because you have same subjects that you study, you will have more topic to discuss on, right? So that's why they belong to the same 2p orbital. So that's why overlapping is very good here, right? So when overlapping is good, donation will be good, right? So basically what will happen, if you see this here, this is going to be along the period or down the group. This is down the group, isn't it? This is down the group. If you talk about down the group, right, either you can just directly cram that down the group along the period, electron donation extent always decreases. If you want to understand it this way. Here the vacant orbital is nothing but it is 2p. Here the fully filled lone pair are in 2p. So 2p overlapping is greater than 2p 3p overlapping. That's why here back bonding will be more. So this is going to be more stable. So A is going to be more stable carbocation as compared to B. Got it everybody? Right? Okay. Here the extent of back bonding is more. More the extent of back bonding, more stability it will provide, right? Okay? Yes? That's why down the group extent of donation decreases. So A is going to be more stable as compared to B. Not B is not more stable than A. B. A is more stable as compared to B, right? Now, next question is, you have this thing, this is A, this is B. Now see this thing. Now again, I'll never ask you to directly answer it, right? Always write Barhi, because otherwise in direct cases sometimes you end up doing wrong, right? So back bonding, is it possible? Yes, this is one lone pair, this has two lone pairs, right? So that means back bonding is possible here. So we'll not look for others, we'll just focus on back bonding here. Back bonding means this is along the period, right? this back bonding is along the period, and I told you along the period because of the electron negativity. Here nitrogen be like, I am not so clever buddy, right? I have only one lone pair, but I can donate you that, right? He's like, I have two lone pair, but I will not donate you that. So he is better, who has less lone pair, at least he is able to donate. Carbon needs only one lone pair. Even if it has two lone pair, he is able to donate. What he will do with that, right? So if he is able to donate the lone pair, this will become more stable. Along the period, extent of electron donation decreases. So here you can say A is more stable as compared to B. Right? Okay. Right, everybody, do let me know in the chat box if that is clear. If that is clear, do let me know in the chat box. Is that clear? Okay. Now, next is this compound, if you see, right? This, if you see, this is A, this is B. Again, we'll draw Barahi. Write it down in the chat box. Barahi. Everybody, spam it in the chat box. Barahi. Right? Okay, Barahi. Thank you, Vivna. Thank you so much. So, firstly, I'll look for back bonding. Can you see anywhere back bonding anywhere in these, out of these structures? Nitrogen has lone pairs. We know that nitrogen, when it forms 3 bonds, it has lone pairs. Here I can see, can you find out? This is where back bonding is happening. Electron rich, electron deficient. This is the back bonding that we were looking at, that we were looking for, right? So now it has back bonding, right? This does not have back bonding. You can say no back bonding, no back bonding, right? In this case, you have back bonding. Do we even need to look at anything else? Tell me. One has back bonding, other does not has back bonding. Definitely, A is going to be more stable as compared to B, because back bonding makes the compound stable. Okay? Got it? Yes. Next is A and B. Let's discuss about this. Let's discuss about this. This is nothing but this is C, F, F, F. This is carbocation. Here it is C, Cl, 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 carbocation. Let's see and draw Barahi. Barahi. So first is back bonding. Can you see back bonding anywhere? Can you see back bonding? If I see this has lone pair of electrons, right? This has, all of them has lone pair of electrons, right? All the fluorine has lone pair of electrons. Tell me. Chlorine also, ma'am, has lone pair of electron. Now, let me see how many of you can answer this. Based on that down the group and along the period, the extent of electron donation decreases. So, both will show back bonding. Both will show back bonding. But here what will happen? This is 2p, 2p back bonding. This is 2p, 3p back bonding. We know that either you learn it this way or you understand it this way, that down the group extent of donation, electron donation decreases. So this will donate more electrons to this carbocation. So that's why A is more stable as compared to B. So answer will be A is more stable as compared to B. Understood? Yes. Very good, master. Very good. Yes. Since fluorine is more electronegative, no. This is what I was telling you now. This is what I have told you here. This is what I have told you here. And here too there was no fluorine, na? Yes, no fluorine. This is what I was telling you. Along the period, look for electronegativity. Down the group, look for overlapping. Down the group, electronegativity concept does not dominate. Overlapping dominates. Along the period, electronegativity dominates. If you are not able to recall this in the exam, just remember along the period down the group, extent of electron donation decreases, right? That means back bonding will decrease along the period also down the, if you're not able to understand this, simple thing is back bonding decreases along the period also, and down the group also, in both the cases back bonding is going to decrease. Okay, this is the simplest version of this particular case, right? Okay, and that's how you are going to answer this, that, wait a minute, yes, that A is more stable as compared to B, right? Next question is, you have this ABC. Now in this case, again I'll draw Barhi. Right, Barhi. Now tell me, is there back bonding possible in any case? This is electron deficient, no one is electron rich. Electron rich means lone pairs or negative charge. It is not there. So it is not possible. Aromaticity, nothing is cyclic here, not possible, right? Resonance, definitely not possible. For resonance, you need to have this thing, double bond, single bond, lone pair, double bond, single bond, positive, double bond, single bond, negative, double bond, single bond, free radical, double bond, single bond, double bond. That is the condition of resonance. It is not obeyed here, so resonance is also not applicable. Hyperconjugation. Hyperconjugation is valid only in this case. That means based on hyperconjugation, you can't differentiate it, right? This carbocation is a sp2. Now this carbocation, this is sp2. And for hyperconjugation, the alpha carbon should be sp3. So not valid here, right? This is not at all valid. That means this hyperconjugation is also not valid. So last effect that we are left with is inductive effect, right? So inductive effect is that this carbon here is sp3 hybridized. This carbon here is sp2 hybridized. This carbon here is sp hybridized. And the electron negativity will be of the order sp is greater than sp2 than sp3. This is the electronegativity order of hybridizations. That means this has maximum minus I effect. Electronegativity means minus I effect. So this has maximum minus I effect. This has maximum minus I effect. It is going to pull the electrons towards itself. Now tell me, whenever you have a carbocation, you give the electrons, it becomes happy. You take away the electrons, it becomes sad, right? So that means it is going to pull away the electrons with maximum extent. So this is making it least stable. Already he is poor and you are taking away the electrons, so you are making it very unstable. So answer will be A, B and C. Because here electronegativity is not that high. It is going to pull the electron, but not to that extent as to it this sp is taking the electrons, withdrawing the electrons, right? Okay, so answer will be ABC. Yes, Lakshmi, definitely, right? Definitely. Let's see this. Now the questions will be more of when 2-3 concepts will be applied in one question only. Let's see. So if you see, not even a single question I have done without writing Barhi. That's what I wanted to tell you, that whether it's applied or not applied, you have to write Barhi. Okay, you have to write Barhi, right? So now if you see back bonding, firstly tell me, can you see back bonding in any case? Electron deficient, you can see. Electron rich, no. So back bonding is not there. Aromaticity, this one if you see, this is showing aromaticity. This is PCC is followed. It is planar. It is cyclic. It is conjugated. Electrons are 4 pi electrons. So it is anti-aromatic. And if the aromaticity is anti-aromatic, no compound is less stable than an anti-aromatic compound. Anti-aromatic compound is the most unstable compound. That means already you will write that C is minimum stability, most unstable it is. Now we have to see whether A and B which is more stable. After aromaticity we have resonance. Here you can see resonance. This is not showing resonance, so that means A will be most stable, then you will have B, then you will have C, right? Why C is least stable? Because it is anti-aromatic. Why A is more stable as compared to B? Because this is resonance, here it is no resonance. We don't need to go beyond this, right? Okay? No hyperconjugation we are applying here. You don't even need to apply it. Why we need to apply it? If there is some other compound also that we need to compare this with, then we will apply further other concept. If we are able to solve it with the help of aromaticity and resonance, we will not go further here, right? Okay? That's why this is the sequence. The sequence is this. Firstly back bonding, then aromaticity, then resonance, then hyperconjugation, then inductive. That's how you need to see, right? Okay, so answer will be ABC is the correct answer here. Okay, next question everybody. Next question everybody. Anti-aromatic compound is most unstable. Yes. Okay, very good. So if you see this here guys, this is A, B, C, D. Now things will be more clear in your head. Things as we do the examples, it will clear up all the confusion that is going in your head, right? This lecture I have framed like that only. Right? It's not like I have picked up some random questions. These are not random questions. These are in a sequence. You will see every question is following a sequence. Right? You will see full GOC I have taught you in a sequence. Right? Because that's how it is taught. Right? So, if the sequence you do random questions are done once you are clear about the concept. Right? So, I am teaching you the concept with the help of examples. Right? Now, if you see back bonding, this is positive, right? Wait a minute. This will also be here, right? So, if you see back bonding here, back bonding will be nowhere, okay? Aromaticity, ma'am, benzene is aromatic in nature, right? So what? Everything is aromatic. So we can't differentiate it. Ma'am, resonance will be there, ma'am. Based on this, ma'am, resonance will be there. But resonance is not a differentiating factor. All of them are showing the resonance. So what's the difference it is making, right? So resonance is also not there, right? Next is hyperconjugation. Alpha carbon is sp2, it is also not there, right? Now, ma'am, how we should answer? Based on inductive effect, ma'am, should we answer? Right? Students will answer it based on inductive effect. I'll tell you mistakes I am telling you. Students will answer it based on inductive effect. Ma'am, okay, aromaticity not, ma'am, this not. Inductive effect, ma'am, this is, ma'am, maximum. Ma'am, more plus effect it is giving, making the carbocation more stable. Ma'am, answer will be DCBA. Right? Okay? Yes. This is what you are thinking, right? But I'll tell you how our thinking is going to change here. This answer is incorrect. Now I'll tell you how this answer is incorrect. See, if you, firstly you need to draw the resonating structures of this one, this benzene and CH2 here. If you draw the resonating structures here, we know that this bond is going to shift here, and hence you will have, this is benzene, and this will be 1, 2, this will be double bond here, this is positive, this is CH2. Then this bond is going to shift here, right? Then what you will have? You will have resonating structures you should be proving, okay? This bond, this is positive here, this is double bond CH2. Then this particular bond will shift here, right? Then you will have 1, 2, 3, right? Negative charge is not anywhere now. Positive charge it is there, right? Yes. So now if you see, right, this will shift here, this will shift here, right? And this will be the positive charge, this will be double bond O, this is CH2, right? And here in the end what you will have, in the end what you have is this one, right? If you see, this is the resonating structure, right? Can you see these are the resonating structures? Let's make the resonance hybrid here. This pi electron will revolve, here partial double bond will be there, here you will have partial positive, here you will have partial positive is on ortho and para position, right? That's it, right? Can I say positive charge is on ortho and para position, right? Okay, let's see this now. If positive charge is on ortho and para position, so answer will be based on something. Answer will be based on something else. Let's see. This is positive here, positive here, positive here. This is positive here, 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 positive here. Now you can answer. Now you can answer, right? Now tell me, is hyperconjugation there or not? Now tell me, is hyperconjugation there or not? Answer will change automatically. Answer is going to change here. See, this is the maximum mistakes that students do is don't know where to apply hyperconjugation, where to apply inductive. So this is one of the questions where easily you can do mistakes, right? The student who has never done this question, they will definitely do mistake, right? So because this positive charge is actually not here only, it is here also, it is here also, it is here also. So the alpha carbon to this positive charge is this one. Here the alpha carbon is this one. Here the alpha carbon is this. Here the alpha carbon is this one. Here the alpha carbon has 3 hydrogens because this is CH3. This alpha carbon is CH2. So this has 2 hydrogens. This has 1 hydrogen because it is CH, then CH3, CH3. This has no hydrogen. So we can say this has 3 hyperconjugating structure, this has 2 hyperconjugating structure, 1 hyperconjugating structure and no hyperconjugating structure. Can you see the answer has changed, right? The answer is A, then B, then C, then you have D. And that's how you have this answer, right? Tell me, is that clear? Why not inductive? Because inductive is after hyperconjugation. We were in an illusion that hyperconjugation will not be obeyed. If you see, in reality, hyperconjugation is obeying there. If hyperconjugation is obeying, you will not see the inductive. It's like priority. If hyperconjugation is giving you a different stability order, inductive is going to give you a different stability order, you will go for hyperconjugation, right? If hyperconjugation is not valid, then only you will see the inductive effect. Okay? Got it, everybody? Any problem here? Any problem here? Tell me in the chat box. Everybody got it, right? Okay. Now, see this question we have done. Now, similar question, if you see, here it is on the para position. Same thing will be on the ortho. So, I will write same thing you will do, same on ortho. Even if you have this group here, here, and here, and here, that will give the same effect. Because ortho and para has positive charge, so hyperconjugation it will show. Now let's see the same kind of compound, but here the extra chain that is attached is to the meta position, right? And if you see this here, if you see this particular structure here, tell me, can you see at meta position there is any positive charge? This is ortho, this is meta, this is meta, this is para. Meta does not have any positive charge, right? Meta does not have any positive charge. Now you can't say that positive charge is over here. Positive charge is here, here and here, right? So if to meta position, if this is attached, it will give us no benefit. It will give us no benefit. Now again write Barhi. Again write Barhi. Right? Back bonding is not applicable, that I can say. Aromaticity is not applicable. Resonance, because of resonance, all of them are showing resonance, and positive charge is distributed like that. Hyperconjugation, is it valid or not? Tell me. It's not about instability. It's not at all about instability. Meta position says that at meta position you don't have any positive charge only, right? So here this was the positive charge. This is the carbocation or this is the carbocation. So when any chain is linked to this one, then that will become the alpha carbon, right? Okay, and the alpha carbon is sp3 hybridized. But in this case, nothing like that is happening. In this case, meta does not have any positive charge. So, cation is here, here or here or here. Nowhere you can see alpha carbon which is sp3, right? Alpha carbon which is, if you say ma'am this is cation, this becomes alpha, this becomes alpha. This is not becoming alpha. So, that's why there is no benefit, right? So, that's why this hyperconjugation is not valid here. Understood why hyperconjugation is not valid here? Yes, everybody. Understood or not? Why hyperconjugation is not valid? It's a very, very important thing, right? So now it is based on inductive effect. Because hyperconjugation is not valid only, then we will look for inductive effect, right? Now if you see, this is CH3, right? It will give inductive. This is CH2. More the number of carbons, more will be the inductive effect. Here you have 2 CH3. More the number of CH3, more inductive effect will be there. And here you have 3 CH3. More the alkyl groups, more the inductive effect. So maximum inductive effect is shown by that is D. This is A, this is B, this is C, and this is D. According to inductive effect, the answer will be D, C, B, A. Okay? Tell me everybody, right? Yes. Due to meta position, no positive charge. Okay? Got it? Right? So, that is done. Now let's see this, okay? Let's see this. Let's see this one. Try to answer. I am writing here Barhi. I am writing here Barhi. Barhi. Beta, back bonding is when you have a positive charge, you have a lone pair here. That means electron rich and electron deficient are adjacent to each other. That is back bonding, right? So it will donate. Or you have vacant orbital. Then you have some negative charge, right? Okay, that is back bonding. Okay, now let's see. Barhi. Barhi, back bonding. Can you see back bonding anywhere? Wait a minute. Right, whenever you see this kind of thing, write the resonating structures. If you see this here, first you tell me, just by this one glance, can you see back bonding here? Can you see back bonding here? Tell me everybody. Can you see back bonding here? Let's see. Can you see back bonding? Back bonding, everybody. Yes. Ma'am, where I can see back bonding, right? But if you see this here, right? Okay. What Swarna? CBA, okay. First tell me what I am asking you. Can you see back bonding here or not? Will back bonding be there or not? You can't see back bonding here, right? I'll show you back bonding. Whenever you see this kind of structure, remember it in the resonating structures, it has positive charge at ortho and meta positions. These are the kind of questions that you should be pro in if you want to crack JEE, right? Now can you see back bonding? Now tell me. Now can you see back bonding? Yes, Harini, Ramaraju, Master, yes. Swarna. Now tell me. Can you see back bonding now? Isn't it visible now? This is having lone pair, this is having 2 lone pair, this is having 3 lone pair. Isn't it the same case that we have done 3-4 slides back? Right? Now see one thing. Now you can see back bonding. This is a case of back bonding, ma'am. This is a case of back bonding, ma'am. This is a case of back bonding. Tell me one thing. If you have NH2 here, if you have OH here, if you have Cl here, then can you see back bonding there? Will you see back bonding there if you have at meta position? At meta position, will there be any back bonding? If they are at the meta position, will there be any back bonding? Right? Will there be any back bonding? Yes, everybody? Tell me. Yes? No. Why? Because meta position, there is no positive charge to show back bonding, right? So back bonding is observed if it is located at ortho and para position, right? Okay, good. That means you are able to understand things. Good. See this now. This is along the period or down the group. This is along the period. I told you along the period. Along the period, the extent will decrease. The extent of electron donation will decrease because of the increasing electron. But no, wait a minute. This is not actually along the period. These belong to a different period. That belong to different period. So things will be different here. This will be 2p. This is also 2p. This is 2p. This is also 2p. This is 2p. This is 3p. So firstly, let's focus here. 2p, 3p, automatically this will be firstly decreased, right? That means C will be minimum stable. Why? Because 2p, 3p overlapping is less as compared to 2p, 2p overlapping. Now between 2p, 2p overlapping, this is nitrogen which is less electronegative. It will be able to donate with more efficiency. Right, so that will be A will be more, then you will have B, then you will have C. So answer will be A, B, C. Right? Okay. Right, everybody? Good. Okay now. So A, B, C is the correct answer. Next question, let's see that here. Let's see that here. This though you can answer easily. This you can answer easily. Yes, everybody. Let me see. Let me just put a poll here. Let's see if you can answer that or not. That I'm not able. Chalo, no issues. Let's see if you are able to answer this or not. Right? So if you see this here, this is 2 carbons. Okay, firstly let's draw Barhi only. Let's draw Barhi. Right? Back bonding, no aromaticity, no resonance, no hyperconjugation. Yes, ma'am, this is alpha. This is having 2 hydrogen. This is alpha. This is having 2 hydrogen. So, hyperconjugation it is showing. But based on hyperconjugation, both have 2 hyperconjugating structures. So, we are not able to differentiate it with hyperconjugation. So, we'll say no here. Right? Now, based on inductive effect, now you have to tell. Right? This is 2 carbon, this is 3 carbon. Which will have more inductive effect? 3 carbon will have more inductive effect. So answer will be B is more stable as compared to A. More the number of carbons of a primary chain, primary carbocation, more will be the inductive effect, right? That we have seen in the first class. Yes, B greater than A, right? Next question here. Next question here. This is A and this is B. Let's see which is more stable. Yes. Yes, which part? Which part do you want me to explain again? See, I was telling you that firstly, hyperconjugation is there, right? But both are 2 hyperconjugating structures. But this is 2 carbon, this is 3 carbon. More the number of carbons, more will be the inductive effect. More inductive effect. Plus I, if you have a carbocation and you are donating it electrons, it will become happy. So more will be the stability. Okay? Yes. Now see this here, everybody see this here, right? Again, let's see, BARHI, right? BARHI, yes everybody? So, now if you see, here you have back bonding, is that anywhere? Can you see back bonding anywhere? Back bonding, ma'am. Electron rich, electron poor. Electron rich, electron poor. No, there is no electron rich adjacent to electron poor. So that means back bonding not applicable. Aromaticity, there is no conjugation here. Aromaticity not possible. Resonance is also not possible. We can't see any resonance here. Hyperconjugation. This is alpha, this is alpha, this is alpha, this is alpha. This has 1, 2, 3, 4 hyperconjugating. This also has 4 hyperconjugating. So, hyperconjugating structures are same in both the A and B. That means based on hyperconjugating also you can't answer this, right? If you say this is alpha, to complete the tetravalency, here you will have 2 hydrogen, this will be CH2, this will be CH2. So 4 hyperconjugating both have, so we can't differentiate, we can't predict which is more stable based on the hyperconjugation, so that is also not applicable here. Based on hyperconjugation, we can't define it. So rest we are left with inductive, right? So in based on in N2 is very good, very good. So now if you see this here, this carbon, if I want to draw it in like in a better way, I can write it like this. Me means methyl, right? So can I write it in this way? Can I write it this way? CH3, CH3, CH3. So here you have 3 plus I effect, which is donating. At the same position, this is not, you can't say that this is showing resonance. NO2 shows mesomeric effect or it is meta-directing only in case of benzene when it is under some resonance. This is not a benzene ring, right? This is not a benzene ring, right? So that is why this is only acting as a minus I group, right? So this is minus I, it will take away the electron. Based on inductive effect you will answer. So when something is already poor, you are taking away the electron, you are making it less stable. So that's why A will be more stable as compared to B, because in A you are donating the electron, right? Okay, yes. So A will be the greater effect. Now here I will just make it little more tricky for you. This is one of your PYQ only. Now let's see. Now let's see that. Which is more stable, A and B? This is very important question. This is important, right? This one is very important. Let's see that. This one is very important, everybody. Let's see who can answer this. Let's see who can answer this. Due to back bonding, A is greater than B or B is greater than A. Okay. Master is saying B is greater than A. Then Abhishek is also saying B is the correct answer. Very good, very good. Most of you are saying B is the correct answer. Okay. You are saying B is the correct answer. Now I'll tell you A is the correct answer. Let's see how. Okay. So these weird questions are there, right? So let's see. Okay, how means full these kind of questions actually students are tend to make mistakes. That's why I asked you. Now if you make the resonating structure here, can you see the resonance over here? These are the lone pairs. These are the lone pairs. Here you can see the back bonding. Here you can't see the back bonding, but sometimes it is hidden. If the bond is shifted here, it will make a bond here and the carbocation will be here and the lone pair is here. Now can you see here it is showing, this part is showing resonance. Then after resonance, the structure that you have formed is showing back bonding. This is resonance plus back bonding. This, if you see, this can either show back bonding here or it can show resonance here. It will prefer back bonding. Because back bonding is more stable, it will prefer back bonding. So here in A structure you have back bonding plus resonance. Here there is only back bonding. So see, something was hidden and this is your PYQ, right? So A is more stable as compared to B, right? Understood? See how they ask you the questions, right? So more you practice, more better you will get, right? If you don't practice things, then obviously you will find it difficult, right? But keep practicing. More you practice, you will make mistakes and you will learn something out of it, right? And at one point you will be pro in it. Now let's see this question, right? Let's see this question, everybody. So good question now? Yes, right? Yes. Tricky questions, yes. That's why I am here. If I am only teaching you simple questions, this is back bonding, then you'll be like, ma'am, we can do this ourselves as well. Ma'am, okay. Ma'am, tell us something. Have you seen that? Organic chemistry in the class. Organic chemistry in the exam. Right? So I don't want to give you shock in the exam, right? So better you get shocked here, right? So if you see this is A, B, C, and these are not actually difficult ones. These are easy only. It's just that if you see this, you will find it easy. If you don't see this, you will find it tough, right? So now if you see this here, now write Barhi again, If you see this here, back bonding is not there, aromaticity, no resonance. Hyperconjugation, there is no alpha carbon here, no hyperconjugation. Inductive effect you have here, right? Inductive effect of 3T, 3D or 3H. So rather than writing it like that, I'll write it like this. This is D, this is H. Okay, now see this here, This is A, B, C. Inductive effect, we know that the plus I effect order is T, then D, then H. If you remember, we have done this in the first class also. There I directly told you apply inductive effect. Now I am telling you firstly see all the effects, then apply inductive, right? There I specifically choose. If you see, go through the lectures of inductive, hyperconjugation again, I have specially choose those questions where directly that effect was applied. But now I am telling you, apply all of them, then see which is most valid here, right? So it will have the maximum plus I, so we'll make it most stable, then B, then C. So answer will be A, B, C is the correct answer here, right? Okay. This one is also very important. This one is also a very important structure, very important question. Okay, this one is also a very important question that will make you think that yes, something difficult or something nice. I say you will say good question, ma'am, right? So I know right now you will give the answer that is opposite to what you are thinking. If you are thinking, ma'am, A is more stable, you will say, ma'am, no, ma'am, C is more stable, then B, then A, ma'am. Okay, let's see who will answer me the correct answer. Okay, just do guesswork. Yes, everybody, which will be more stable? So I'm just going to, these concepts hold high weightage, no ma'am. Yes, if Sheen, in fact, from GOC, sometimes 4 questions are asked directly from these stability of intermediates. And every single year you will see this, right? 3 to 4 questions from stability of intermediate acidity, basicity are for sure. And these concepts that you can see here, this is applied throughout organic chemistry. Throughout means throughout. For example, you will see a reaction which has the formation of carbocation as intermediate. If you don't know the stability of carbocation, rearrangement we'll learn about, right? In the upcoming lectures, we'll learn about rearrangement of carbocation. If you don't know which is more stable, you won't be able to understand rearrangement, right? So this is actually the most important lecture, right? So if you ignore these things, then full organic, forget about it. You'll only be able to do questions which are cramming based. Logic based questions you won't be able to do if GOC is not strong. It's impossible, right? So now if you see this here, right, the question that usually students say is, ma'am, this is three CT3 groups are attached, so the order should be this. But in reality, the order is this. Why, ma'am? Why so? Let's understand that why. Okay, this is C positive, CT3, CT3, and this is CT3. Okay, this is C positive, CD3, CD3, and CD3. Similarly, you have C positive, CH3, CH3, CH3. Now, if you see this here, BARHI, then tell me one thing. Back bonding is not valid, aromaticity not, resonance not, but hyperconjugation. Ma'am, yes, it is valid, ma'am. Now, what you will think? Ma'am, this is alpha, this is alpha, this is alpha, ma'am, but it has 9 hyperconjugating structure. Ma'am, this also has 9 hyperconjugating structure. Ma'am, this also has 9 hyperconjugating structure. Ma'am, hyperconjugating structure are same. So, this is not valid. This is what you have thought, right? But see, hydrogen isotopes are there. Now, why hyperconjugation? Just if you learn the trick of hyperconjugation, you won't be able to understand this question. But if you know the concept that I have told in you yesterday's lecture, then this question will become quite easy for you, right? This is T, let's say this is alpha, na? This is alpha, this is T, this is T, this is T, right? So similarly, you can write here D, this is D, D, D. Similarly, here you will have H, right? This is H, this is H, this is H. Now all of these are alpha, this is alpha, this is alpha, this is alpha. Tell me what we were doing in hyperconjugation, what we were actually doing, right? I knew it was a scam. Okay, so if you see this question, this is CT, CD and CH. What you do in hyperconjugation, you break this bond. This is converted to H positive and this is double bond is here. That was your hyperconjugation, isn't it? Isn't it? Do you remember? That means in hyperconjugation, you break CT, CH, CD bond. So here CT bond you will break, here CD bond you will break, here CT bond you will break. Hyperconjugation will be more in the case where the bond breakage is easy, right? Where the bond breakage is easy, where the bond strength is less. So the bond strength is, where should I write? I'll just write it here, right? Yes. So bond strength is CT maximum, then CD, then you have CH. That means bond energy required to break the bond will be maximum here, right? So bond strength will be maximum here. So ease of breaking will give you more hyperconjugation, right? That will be maximum in CH. That will be maximum in CH, because in CH the bond strength is very less. So it will be very easy to break this bond. When it is easy to break this bond, so hyperconjugation will be maximum in this case, right? This is the order of hyperconjugation. This is the order of hyperconjugation. So answer, if I say this is A, this is B, this is C, answer will be C, then B, then A is the correct answer here. Okay? Got it, everybody? Understood? Tell me if you have any problem here. And also, students, do like this session. I see you don't comment only. I don't know what I have to do for you to comment down the homework, right? So, Rama, Raju and one more student only has done the, has given the answer in the comment section. Today I want all of you, Abhishek, Anmol, Kiddo, right? Then Swarna, right? All of you, right? Rama Raju, to he always gives his answer, right? Today I'll see if you do your homework or not. I'll see, right? Because you guys attend the lectures with full dedication. So I want you to be dedicated in homework also, right? Okay? Yes. Now, so next question is this one. This you will be easily able to solve. No scam here. No scam here. No scam here. Don't worry. No more question will be a scam based question, right? So, now if you see, in this case, can you see back bonding anywhere? No, right? Aromaticity? No, right? Resonance I can see here. This compound is resonance based. So that's why, because of resonance here, this will have maximum stability, right? Now out of B, C, D, this is showing resonance house of B, C, D. Hyperconjugation, none of them is showing, but they are showing inductive. Hyperconjugation, this will show, but others will not show, right? So we can't define it based on hyperconjugation, right? So this is SP, this is SP2, this we have done before also, this is SP3. So SP has more electronegativity as compared to SP2 as compared to SP3. That means it will pull the electron with max, it will withdraw the electron maximum. So it will make this very unstable, right? So here it will be D, then you will have C, then you will have B. Because of inductive effect, B will be least stable here, right? Okay. D, CB, A, D, CB, okay? Not A, B, C, D. Not A, B, C, D, opposite will be there, right? Why? Because if you have a positive, you withdraw the electron, that will become unstable. Someone is already poor, you are taking away money from them, they will go crazy, na? I don't have money. So what we have seen in Nepal, what is happening in Nepal, right? This thing is happening, na? Middle class is like more, like I can't handle it more, right? More, like enough of this. Fed up of that, right? Because someone is already poor, you're taking away more money from them by giving them taxes and all, right? What they will do? They will become unhappy. Same situation here, same situation. See, chemistry is related to your daily life, right? So that's what I tell you, right? Okay, yes. Now, next is this one question on your screen. If you have here, this is BARHI, and if you see this here, this is going to show you back bonding here. This is back bonding. So B will be maximum stable. In A and C, if you see, back bonding, according to back bonding, B is maximum stable. Aromaticity is not shown by anyone. Resonance is not shown. Hyperconjugation, this is also CH2, this is also CH2. Both the alpha carbons are same. So, no hyperconjugation will tell you that which is more stable. Inductive will tell you. If you say inductive, this is going to pull the electrons. Oxygen is going to take away the electrons. Some students, they misunderstand by, ma'am, this has lone pair, ma'am, it is going to donate. Arey, lone pair will be donated if there is some resonance, right? Or if there is some back bonding, right? Otherwise, it will show inductive effect, right? So here, it will pull out the electron with minus I, right? It will pull out the electron. So it will make it very unstable, right? This, no one is there to pull out the electron, no one is there to give the electron also, he is happy. So more happy than this. So answer will be BAC is the correct answer here. Very good, Prem. Prem also, BD, Harini also, you need to write it. Okay, Pranay also, I will be waiting for your homework. Pranay, Prem, Harini, Swarna, right? Everyone here. Okay, yes. So, BAC. Next is, this is one of the exceptions that you have, right? Now again, here what you think and what is the reality is exactly opposite. This is the exception. In this case, Barhi is not applied only, right? Because what we know is back bonding is not there, aromaticity is not, it's actually pH means this is benzene ring, right? So I'll just draw the ring here, right? And this means that you have 3CH3. When you open up the structure, it becomes quite easy for you to understand, right? So this is CCH3. Right? Now here, what is the situation? You will say, ma'am, here we have resonance, right? Ma'am, so because of resonance, this will be more stable. There, ma'am, we have inductive effect, it will be less stable, right? That should be there. I understand that should be there, but it is not there, right? So that's why this is under the case of exception, right? So when you have here 3CH3 group, that will overshadow one phenyl group. It's like you have, oops, so sorry, okay, it's like you have one big like dawn over here, dawn, or you can say one big wrestler over here, right? Other are normal people, 3 normal people. So when one normal people will attack this wrestler, obviously he will win. When non-normal person will attack the wrestler, obviously he will win, wrestler will win. But when 3 normal person who don't have any body or anything, they will simultaneously attack the wrestler, then wrestler will lose. Why? Because 3 normal persons have enough strength to defeat a big wrestler also, right? So it's like unity, right? So here you have 3 methyl groups, that's why it will overshadow this resonance here, right? So that is why here A will be more stable as compared to B. This is an exceptional case where inductive effect becomes more preferable, right? Okay. Yes, everybody? Yes, unity effect. Inductive effect, unity effect, right? So here, if you say, ma'am, there is only one CH3, then obviously this will win. If here you have 2 phenyl, then also this will win. Here you have 1 phenyl and 3 methyl. In that case, this will win. Okay? Okay? Yes. Yes, everybody. Now, this we have done. Next is, this also we have done. Next is carbanion. Now, carbanion will, same thing we will apply here. Okay, let's talk about the carbanion. Let's talk about carbanion. I don't know why it is showing it's 1 p.m. Something has happened to my board, right? Sometimes it is showing 8 p.m. in the morning, right? It is showing in the at 9:30 p.m. What is the time? At 9:22 p.m. it's showing 1 p.m. lunch time. I don't know what is wrong. And like organic has made my board go crazy, right? So this is A, this is B, right? Now again we'll do Barhi. Barhi, Barhi, that is our life. Okay? Back bonding, let's see. Here is a different concept, right? This is negative, you need electron deficient, right? So out of oxygen and sulfur, which is electron deficient? So sulfur is electron deficient. Sulfur has vacant d orbitals to accept electrons. Oxygen does not have any vacant orbitals. So this will show no back bonding. No back bonding. This will show back bonding. This will show back bonding. So A will be more stable as compared to B. Right? Remember one thing, that second element of P block has vacant d orbitals, right? That means the one that are belonging to the third period, right? So by back bonding, A is going to be more stable as compared to B, right? No inductive effect will be here, right? This is not based on the inductive effect. This is based on back bonding, right? Okay, because of this concept here. Got it? Yes. Everybody got it? Yes. Now, next thing is this question here. This is a similar question. We have done the similar question before also, right? In carbocation also we have done a similar question. That is that if you talk about back bonding, it is nowhere to be found. Aromaticity, yes. This is aromatic in nature. PCC is followed, it is planar, it is cyclic, it is conjugated, it has 6 pi electrons. So it is aromatic in nature. Aromaticity I have told you in the last lecture. 1, 2, 3, 4, 5, 6 pi electrons. That means 4n plus 2 pi electron. That means it is aromatic. That means A is going to have the maximum stability. Aromatic compound is maximum stable, right? This is going to be, now some, if you think that ma'am, then if in calculating aromaticity it is aromatic, you will place it in the front. If it is anti-aromatic, you will place it in the end. Then ma'am, what about non-aromatic? Non-aromatic, you will see some other effect that will be applied. This is non-aromatic, this is also non-aromatic, right? You will see some other effect that is applied, right? Here it is resonance, so B will be here. This is no effect, right? So based on aromaticity and resonance, we have answered A, B, C is the correct answer here. Okay? Why C is more? Here you have resonance, there you don't have any resonance. Right? So A, B, C is the correct answer. Okay. Right? B is not approximately equals to C because here you have resonance, here you have no resonance. So definitely this will be more stable. Right? Okay, everybody? Tell me. C is aromatic. How C is aromatic? Acha, C is aromatic. Okay. What about this PCC? Planarity. This is sp3. This is sp3. This is sp3. Not revising the chapter, kya? You're not revising. What about cyclic? It is planar. It is not. Conjugated. Where you can see full conjugation here? Nowhere we can see full conjugation. So this is definitely not aromatic. Right? Okay. Yes? Okay. Yes, everybody? Clear, clear, clear? Next, let us see this question here, and this one is also very interesting. Okay, this one is also very interesting. My idea is by the end of October, right? Yes, because we are only left with organic, right? Or organic, so don't worry, every single thing will do, don't worry, right? Now, let's see this. If you talk about this here you have BARHI, right? Back bonding is not anywhere, right? Back bonding, you can't see electron rich, electron deficient. Aromaticity is not there, resonance is not there, hyperconjugation is not there. In carbanion, never there will be hyperconjugation, except for then minus H that I have told you. Inductive effect will be there. Now don't say ma'am this will give ma'am plus, no, I am talking about inductive effect. If you talk about resonance effect, all of them are showing resonance. So there is no differentiating factor on that, right? Moreover, this is negative. How it will show, right? So it will show minus I. It will show minus I. Okay? It will show minus I effect, right? Now, when it is showing minus I effect, then what you will do? Now, ma'am, it is showing minus I is very near, so more electron it will be able to extract. It is far away, right? So, more electron extraction, more happy it is. Carbanion is like stress. When you have so much stress, someone is taking away your stress, right? You will feel happy, right? Someone is giving you more stress. You're already, oh my god, my syllabus is not done, I have so many backlogs. Someone is like, oh my god, your backlogs are there. Oh my god, this is there. You don't know anything. Oh, you are stupid, you are dumb, you don't know anything. You won't be able to crack. What you will feel? You will be like, I could have cracked, but because you just motivated me so much, now I definitely won't be able to, right? So when you're already under stress, someone is giving you more stress, you will feel unhappy, right? Someone is already under stress, someone is taking away stress from them by minus I, and they are very near to you. It's like your friend who is next to your house, neighbor. You're just like, I'm so sad today, I'm not able to solve these questions. They'll be like, don't worry, I'll just come to your home, don't worry, right? Now your friend who is living in next colony, you're like, hey buddy, I'm so sad today, can you come over? You're like, okay. This is staying in some other city, you're like, hi, how are you, I'm missing you and all that. They are living very far away from you, right? So less effect will be there, right? So that's why A, then you have B, then you have C, right? Okay. Yes, everybody? Okay. Okay. Yes. Now what about this one? Here again Barhi, right? But in this case, back bonding, no aromaticity, no resonance, no hyperconjugation, no inductive effect, yes, right? Same as before, but this is showing plus I. Somebody is already under stress, negative. You're giving it more stress. They'll be like, get lost, please get lost. He is away from you. It's like your enemy who is living in your neighbors. You'll be like, daily I have to see this person. You'll be like fed up of them. You hate someone, but they are living in some other city. You're okay, you're fine. You don't have to see their face daily. So here C will be more stable, then B, then A, because enemy is far away. If enemy is far away, then it's good, right? Okay, C, B, A, right? Okay, yes. Okay, very good, very good. Vanakkam. Yes. So now let's see this. This is a very important question. Very, very important question. This is actually from inorganic chemistry as well, right? So this can easily be asked to you, right? Okay, dosa system. Yes. So now tell me about this one. If you see this here, BARHI. I'll just draw it like this. CCl, Cl, Cl negative. This. Now see this here. Okay. Now see this here. Right, everybody? Now see this here. This is negative. You need something which has vacant orbitals. Fluorine and chlorine. Tell me out of this, which is the second element? Chlorine is the second element. So chlorine will have vacant orbitals. Fluorine will not have vacant orbitals. D vacant orbitals, or you can say vacant d orbitals. Because it has vacant d orbitals, that is the reason this shifting can happen, right? So you can say this will be more stable. A is more stable as compared to B. Reason is because of back bonding here. Reason is because of back bonding here. Right? Okay. Yes. Definitely, Tushuma. Definitely. In second attempt, though, you have so much time. Right? If you start preparing now, I think even in first also, if you actually genuinely prepare well. Right? Okay? So now let's see this one. Here. Again, let's write Barhi. I know you are at this point fed up of writing Barhi, but this is how you solve it, right? Back bonding is not there, aromaticity not, resonance not there, hyperconjugation not there, inductive you have. This is sp, sp2 and sp3. So if you see this here, sp is actually more electronegative, then sp2, then you have sp3. This is the situation that you are in, right? This is the situation that you are in. So when someone is negative, someone is under stress, you take away the electron from them, they become happy. You give the electron, they become sad. Because someone is already negative, you give more electron, they will be unstable, right? So here you are taking away the electron, that is a good thing for carbon ion. If here it would be positive, then the answer would have been, this is the correct answer. But here it is negative. So that's why negative means you take out the electron, it is happy. So this is happy for that. So answer will be A, then B, then C is the correct answer here. Okay? Got it? Yes, it depends, right? It depends that whether you have carbocation, carbanion, this I have explained you before also. Take carbocation, right? Take carbocation, this is carbocation, this is carbanion, right? What you have to think that when carbocation you are donating, you are taking it away. Here you are donating, here you are donating, right? Here you are taking away the electrons, here you are taking away the electrons. Think about carbocation as money. Think about carbanion as stress. When someone gives you money, you become stable, you become happy. When someone takes away money from you, you become sad, right? When someone gives you stress, you become sad. When someone takes away stress from you, you become happy, right? That's why this is the situation, right? Good class, nice explanation, ma'am. Thank you, thank you. Oh my God, my local coaching institute ruined my prep. I want to get you as a teacher. Thank you so much. Thank you so much. That means a lot to me. Thank you, Tushma, Prem, Latika, Swarna, Abhishek. Thank you so much. Thank you so much for that. Right, this actually makes me so happy. So I take, that's why I ask you to comment down in the comment section just after the class. When I end the class, comment it down, because that is a motivational dose for me. See, from today I am taking the classes. Today firstly there was a class at 2:30 on Sigma batch. Then 4:30, no, this was in my NEET batch. This one in my Sigma batch class, right? Then at 8 also I have this class. So I was almost like drained, literally. But then I was like, okay, fine, let's take the class. So why we take the class? Just for you guys, right? Because it makes us feel very happy when students who are not able to understand anything, maybe they were getting good content on some channels which language they are not able to understand. So English is something that every school teaches English, right? So that's why when you don't get a quality content in your own regional language, right, English is understandable, right, and moreover your exam is also in English. That's why more students, right, there is no language barrier, right, more students will get connected. And maybe someone out there who is thinking that I am dumb, I don't understand anything, maybe the approach is not right. So I have seen so many students who, even in the batch also, right, even in batch students are like, ma'am, we were never able to understand these topics, but now we are able to. Why, ma'am? We used to feel that we are dumb, we don't understand anything, maybe we are not intelligent, right? Now they are confident. Why? Because the approach is correct, right? So I think approach by a teacher and hard work by a student, both are needed. That's why from my side I am giving full hard work. From your side, what you need to give is at least start doing the homework, right? Okay, right, everybody? Yes, thank you so much, Latika. Thank you so much. That means a lot to me, right? A lot to me, right? Thank you so much. Okay, now let's see the next one. This we have done. Okay, tell me about this one, A and B. Again, we'll draw Barhi. This we will draw. No matter how tired you are of drawing Barhi again and again, you will draw. This habit, I am also fed up of writing Barhi again and again here, right? It's irritating for me as well. But I am writing because I want you to have this habit of writing this again and again and again, because sometimes back bonding is applied but we ignore it. Aromaticity is applied but we ignore it. That's why writing this again and again is important, right? Okay, so this is a habit that you should have. Back bonding is there? No. Aromaticity, yes. Here if you see, this is PCC is followed. It is planar sp2, sp2, sp2. Cyclic, it is conjugated. This is applied. Then it has 4 pi electrons. So it will be anti-aromatic. Anti-aromatic will be most unstable no matter what. So directly A will become more stable as compared to B, right? Okay, yes. Okay, everybody. Yes, everyone. Yes. You took for us, ma'am. Acha, Anmol. Yes, that's what I was thinking. Anmol was there in a batch also. I thought some other Anmol is there. Yes. After 2:30 again, I had class at 4:30. It was like going and going and going. Like, that's why my throat is little bit blocked at this point. You will see. Otherwise, my energy is higher than the energy that I am showing right now. But my throat was totally blocked. I was like, okay, let's drink tea and get energy. Right? Okay. So, is there in DNA batch one this year, but I'm in school every time in time of chemistry class. Oh, Latika, that's really sad. What to do? We have tried our best to make the classes, but we can't make the classes at night, no? So that's why we also have to give you proper 3 to 4 classes. So that's why we have to start at 2:30, right? But don't worry. You write anything, any doubt you have, Latika, you can contact me on Instagram, Telegram, anywhere you can contact me. Just tell me that, ma'am, this is my query. Right? Okay? Yes. Chal. Now tell me about this one. This is also very interesting question. A, B. Write down barihi, barihi, barihi. Right? This is very interesting question. Let me see who will answer this. I'll tell you. I'll explain. Don't worry. This is a scammer question. Again a scammer question. This is CH2 negative. Right? If you see, this is donated here, this is jumped here. So here you will have, this is negative, this is double bond, this is CH2, right? Then again what will happen, this will jump here, this will jump here, right? Again what you will have, this will be double bond and this will be negative, double bond, this will be CH2. Again what will happen, this will shift here, this will shift here, right? Now how to draw resonating structures, that you should be pro in, right? Okay, try to draw it yourself as much as possible. I know this is not a ma'am subjective exam, ma'am, why you're asking us to draw it? Because in conceptual based questions also you should be able to understand what is the concept exactly, right? Now these are the resonating structures. Now can you see one thing here? At ortho and para position, I'll draw the resonating structure, resonating hybrid here. Pi bond is overall, right? Here you have partial double bond. Here you have partial negative. 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 That means at ortho and para positions, you have partial negative charge. Right? Okay. Yes, Ramaraju, I'll do that. Yes. Okay. Yes. Now let's see here. Now if you see ortho and para is negative. That means here you will have negative. This negative charge is not only concentrated to this place. This is a scam. You need to be aware of that scam. This is hidden somewhere. This question, something else is hidden here, right? So this negative charge is actually on the ortho and para position. Now, once you are clear on this thing, now question you will be able to understand, right? Okay, yes. Now you will be able to understand this question that is back bonding here or not? Tell me now, is back bonding here? Can you see this thing? Can you see this thing? Can you see this thing? This is nothing but this is negative. This is P positive. This is carbon negative. This is P positive. If you see this thing here, phosphorus, right, you have phosphorus is having empty p orbital. Ma'am, positive is here also. Don't go for positive only. Positive is here also, Me3 is here also. The differentiating point is here you have phosphorus which has empty p orbital, right? So you will write it here. P has empty d, not p, empty d orbital. To accept electrons and show back bonding. These things I am writing so that in the notes you will get the clarity about these things, okay? Okay. So if you see this here, this will be negative, this will be negative. This will show back bonding. Nitrogen, phosphorus, this belongs to second period. Right? So this question you have answered based on back bonding. Right? This question you have answered based on back bonding. Right? Yes. Okay. Yes, everybody. Beta, see. You are saying, ma'am, N has pp orbital. Nowhere I have told you that in carbanion you will see overlapping. You will not see overlapping here, right? You will not see overlapping here. You will see the vacant orbitals, right? This has vacant orbitals. This does not have vacant orbitals. Where it will accept the electron? Electrons are donated by this carbon. It needs some space. It's like when, let's say, some guest is coming at your home, right? See, we are Indians, we are like Atithi Devo Bhava, right? We are like guests are always welcomed in our houses. So, but for example, 50 people are coming at your house, right? And you have just 2 rooms, right? So you don't have vacant orbitals where you will accommodate them, right? So this phosphorus has vacant orbitals, only then it can accommodate, right? Yes. Ma'am, it has lone pair. Which has lone pair? So lone pair to we don't need, na? Lone pair we don't need. Either ways, lone pair it is actually, right now lone pair is making a bond with this benzene. But why are you focusing on, this is negative, this is lone pair, right? If there is negative, you need a vacant space here. If there is positive, then you will look for lone pair or negative charge. Okay? Rich and poor. Whenever you see a carbanion, you will have to see vacant spaces. Right? Okay? Yes, everybody, tell me in the chat box if that is clear. When you have, okay, what I am telling you, if there is any confusion in this concept, see. Back bonding is when you have a carbocation, you will see that where you have lone pair, you want to see lone pair, or you want to see negative charge, which is electron rich. When you have C negative, you are looking for vacant d orbitals. Vacant orbitals where it can accept, that means electron deficiency where it can accept. Okay, so it is done. Yes, it is done. Now next is, we are almost towards the end only. Then we are going to see some 2-3 questions, PYQs, right? Now if you see stability of free radical here, again write down BARHI, Barhi. Again write down Barhi, right? BARHI, right? Now if you see this here, back bonding is not possible. There is no electron deficiency or richness here, right? So aromaticity, is it possible? No. PCC, planarity, some students say, ma'am, this is aromatic. No, aromatic how? This thing is not aromatic. Either ways, I'll tell you one thing. Phenyl free radical or phenyl cation, they both are very unstable. They are not at all stable species. They are very unstable species. Okay? So, by just looking at it also, you can say A is more stable as compared to B. But if you want to see aromaticity is not there because of resonance. This is showing resonance. So, because of resonance, this will be more stable. And here, this is automatically a very unstable compound. Right? Okay? Yes. Yes, everybody? Got it? So you complete my backlogs from first, and should I continue with the daily lectures, ma'am? Latika, the rule is that right now we are doing in DNA. If you are in DNA batch, then we are doing organic chemistry right now. So GOC you can complete from YouTube, right? Watch my lectures on 2x, right? And after that, automatically organic is going on there. Then you will have some physical chemistry lectures that you will be left with. Keep every Sunday for at least one subject, one chapter you should do, right? Okay. If you want to complete backlogs, it's not like you want to create new backlogs. Don't create new backlogs to finish off the old backlogs, right? Now this one is the last question. Let's see who will do this. BARHI, Barhi, Back bonding, I can't see anywhere. Aromaticity, no. Resonance, we can see over here, this is resonance, right? This does not show resonance, so because of resonance, this is more stable. So directly we can say A is more stable as compared to B. Right, everybody? Okay. Yes, students, now let's do some PYQs. Let's do 3-4 PYQs I have for you. Let's do that and let's end the lecture then. Let's end the lecture. Firstly, let's do the PYQs. Yes, everybody? Ready for it? Ready to give me the answers? This we have done before also, right? But now the way of looking at this question will change. We'll look at it as Barhi, right? Way of looking at every question will change. In which pair the first ion is more stable? If you see this, we have done in resonance as well. See, back bonding, can you see over here? This is back bonding. This is inductive effect. This is showing inductive effect. So definitely back bonding is more stable as compared to inductive. Can you see back bonding more stable as compared to inductive? So definitely this is a, here this one is more stable. Okay? Can I see? If you look at this one, yes everybody, if you look at this one, here you have carbocation. If you look at Barhi, back bonding no one is showing, aromaticity no one is showing, resonance this is showing resonance. Can I see? This is more stable. This is more. See, with Barhi, this question will automatically becoming easy, right? You just have to look at this one. First I see back bonding, anywhere back bonding. These two are the same only. This is carbocation, carbanion. Back bonding to we can't see the back bonding. Aromaticity no, resonance no, hyperconjugation no, it is only here. We need to compare it. So inductive we will see. If you see this here, this NO2, if this is C, this is at the ortho position, it is showing minus I and plus M both. It is showing minus I and plus M both, right? So plus M is more dominating, so with plus M it is increasing the stability here, right? So that means here it is increasing the electron donation, so it will increase the stability on this side, right? It will increase the stability on this side, because to a carbocation, actually don't get confused here, these two are the same things only. They have written NO2 here, they could also have written it here, right? Now this will become easy for you. You will see, ma'am, oh same position. Even if you write it here, that is the same thing only, isn't it? So the only difference that they have is this is negative, this is positive. When you give the electron, because plus M is more dominating as compared to minus I. Resonance is more dominating as compared to inductive, right? Except for halogens, right? That we have discussed in resonance also. So plus M is more dominating, so that's why it is going to give the electron, and that's why this will be unstable. What about this one? Back bonding I can see here. Can you see back bonding here? Yes, if it is back bonding, definitely it is more stable. So in case of, wait a minute. This is positive charge. If I see, this is the positive charge. It is not showing. No, we will not actually, this resonance, wait a minute. This actually is opposite. Wait a minute. Why? Because here only minus I will be shown, right? I'll tell you how. Here only minus I will be, yes. Here only minus I will be shown. Why? Because mesomeric effect means resonance. Now resonance if I want to show here, it will be over here. This ortho, this para, this ortho position. Here this is outside. So resonance is not shown outside the ring. Resonance is shown inside the ring, inside that benzene ring. So this particular cation is outside that ring, right? So that means plus M effect is not valid here, right? So it is minus I. So if you take out electron here with minus I, and if you take out electron here from plus I if you take out electron, it will make it unstable. So answer will be, this is more stable. Because when you take out electron from a carbocation, that makes it more stable. Understood now why here meta is not applied? Because meta is valid inside that ring. You are not doing resonance here. You are not doing resonance here. Resonance is only valid till here. Till this position resonance is valid. Okay? Right everybody? Yes. Right? So answer will be in A and B. First will be more stable. So answer will be A is the correct answer, that in A and B it will be more stable. Right? Okay. Next question is based on JEE Mains 2025. Now this is what we have seen before also. This is positive here, this is positive here, this is positive here, this is positive. Do you remember this? This question we have done before also. In today's class only we have done it. That scammer question if you remember, right? So in this case if you see, you will find that ma'am back bonding is in which case? Back bonding is in which case? If you see this, if you make the resonating structure of this one, this will become CH2. This is double bond. This will become positive. This will become fluorine. So that means this is going to show back bonding. This is going to show back bonding, right? If you see this case here, this is also going to show you back bonding. This will become double bond. This will become positive. This will become CH2OCH3. Here you will not see, even after resonance you will not see back bonding. Here if you see, this will be 1, 2, 3, double bond here, positive. This bond is shifted here, this bond is shifted here, this bond is shifted here, this bond is shifted. That's how you are going to answer this, right? Positive, this is oxygen, then you have CH3. So this will also show back bonding. What about this one? What about this one? This is 1, 2, this is O, this is C double bond O, this is CH3, this bond will be here, this will be here. Now let's see which will show back bonding. This will show back bonding, this will not show any back bonding, this will show back bonding, and here this is positive, this is also lone pair, but this lone pair is also in resonance here. So this lone pair is not fully available for the back bonding, so that's why this is already eliminated, right? So back bonding is not strong. A is not showing only back bonding, D is showing, but lone pair is already in resonance with this double bond O. Now you have fluorine and oxygen. Which back bonding is more stable? Here back bonding is there and plus I effect also it is giving, right? Okay. Even if you think only about back bonding here, along the period, the extent of electron donation decreases, right? So fluorine will have, because it is more electronegative, it will have less extent of donation. So this is also eliminated. Answer will be C is the correct answer here, right? Okay, yes. Very good, Abhishek. D is cross conjugation. Very good, very good. Yes, in D it is showing cross conjugation. It will show here also, it will show here also, right? So that's why it is like it is sharing, it's like on two sides, so that way it is not that effective. Very good, Abhishek. Okay, so that is done, right? Next question is, and I think this is the last one. The decreasing order of hydride affinity for the carbocations are. Decreasing order of hydride affinity for the carbocation. Let me see how many likes you have given to this lecture. Just 57 till now. Make it 100 by tomorrow, right? All the students who are watching this on the recorded version, make it 100 by tomorrow, right? So, decreasing order of hydride affinity of the carbocation, if you see, stability of carbocation is inversely proportional to its hydride affinity. Okay. Now if you see, can you see this will show dancing resonance? Isn't it dancing resonance? Yes, everybody. Do you remember dancing resonance? This will be converted to this kind, will be converted to this thing. Dancing resonance. Do you remember dancing resonance? Right? Okay. So this is showing you dancing resonance. 1, 2, 3 dancing resonances. So this will be most stable. D is most stable. After that, if you see, it is actually D Barhi. Dancing resonance is even more stable than back bonding. Now you will see, is there any back bonding here? No. Dancing resonance we know. Aromaticity? No. Resonance? Yes. This is showing resonance, resonance, resonance. So after D you will have B. Right? Then you need to find resonances. Here it is showing 3 resonances with benzene. Here that means phenyl. And here it is showing 1 resonance, 1 conjugation here. So after B you will have A. And here you have only inductive effect, which is in the end. Right? Inductive, not even inductive, actually it's hyperconjugation. This is alpha, this is alpha, this is alpha. It's showing 9 alpha hydrogens. So it is in the end. Right? So that's why least will be this C. This is the order of stability. So order of hydride shift will be opposite here, that is, this is the order of hydride shift. This is the order of hydride shift, that is CABD, right? CABD. So answer is C. They are saying decreasing order, CABD. CABD, CABD. This is the correct answer here. So B is the correct answer. Okay. Thank you, Pandit Ji. Thank you. Right. Achha, where is cross conjugation? Okay. Here he was talking about cross conjugation. If you see this here, this structure. Here, these are the lone pairs. Okay. These are the lone pairs, right? Here, this lone pair can also show back bonding, and back bonding is a kind of conjugation only, right? It is a conjugation. These lone pairs can also be donated here and then extend here, right? So, this is showing conjugation on this side also, that's why it is cross conjugation, right? Okay? Understood everybody? Right? Okay. Yes, students, do let me know in the chat box if everything is clear to all of you or not. Now, who will promise me that they will do the homework, right? So much appreciation you give me. Ma'am, you are amazing. Ma'am, lectures are amazing. I am able to understand everything. That why don't you do your homework, right? Efforts I am putting, you are also putting the efforts, you are also there, you are also listening to me for hours and hours. That's so appreciable, right? So, but what I want is that you do homework also, right? Because if you don't do homework, right, I'll feel like why I am like wasting my time like that, right? So, it also motivates me. I'll bring more DPPs and all for you, right? But if you don't do homework only, then why will I, devote my time to that, right? Okay, yes. Ma'am, kindly give numbering to lecture, please. Okay, Abhishek, I'll give. Okay, I'll ask the team to make a playlist of GOC, right? Okay, once it is, once we have done it, I'll ask the team to make a playlist and name the title, add the title, add in the title lecture 1, lecture 2. This is what happens. My brain is not braining at this point. It's like my brain is like now shut down, right? My brain just got the signal. Now you can shut down. From the morning you are talking, you know. Sometimes I am teaching organic, sometimes I am teaching physical. So the brain is right now like, okay, I want to relax, right? Okay, I think your brain also wants to shut down right now, right? So this is a question, JEE Mains 2022. Take a screenshot here, answer me which of the following carbocation is most stable based on Barhi, right? Take a screenshot here, everybody. Take a screenshot here, everybody, right? Yes. I am waiting for at least 10 homework comments, which I don't see, right? And I feel very bad for those students who give the homework, right? So those who don't do the homework, they are not only doing bad for themselves, but also for others, right? So I am waiting for some students to write down the comments, right, in the comment section so that I can start providing with the DPPs as well. Right? Okay. Okay then guys, now I'll take your leave, but before going, right? Yes. Ma'am, count 1 to 10 after inhaling and closing eyes. Yes. Don't worry. I do yoga daily. Right? So I'll do that in the morning. Right now all I need is sleep and something to eat. So, MDSAT scholarship program guys. Acha, now tell me how many of you have already filled the form? How many of you have registered yourself? Because this is very important guys. Why? Because see, first thing is registration is free of cost. It's not like we're charging you something for registration. It's free of cost, and because you're already preparing for JEE, that way more chances that you will get into this category. If you are in this category, you will get automatically 100% free scholarship, like 100% free. All the courses of Vedantu will be free for you. Like 150 crore worth of scholarship will be provided to you, 2 crore worth of prizes, iPhone, iPads, all these things will be provided to you. Like, I mean, if you don't want it, give it to me, gift it to me, right? Go and crack it. Be in that 2.5 lakh students. You're like, ma'am, I don't want this iPad, ma'am. Please gift it to me, right? But at least go there, right? So here, October 4th, 5th, 11th and 12th, these are the offline center dates where it is going to happen, right? And nearest Vedantu center, right? You can call on the Vedantu center, right? And there, ask that which is the nearest Vedantu, give your address, right? Ask them that which is your Vedantu's nearest center, right? And all these dates are Saturday, Sunday, so that will not be a chaos for you, right? Okay. Okay then. Chocobar also you will get here, right? We are not, Chocobar is very less in front of this. We'll load you with Chocobars, right? So many things will be provided here, right? Okay. Now register yourself and maybe you will be able to meet me as well. Maybe I'll be there in your nearest Vedantu center. You never know, right? So, yes. Okay then students, now I'll all see you tomorrow in the next class. Ma'am, next chapter, isomerism. Next, tomorrow we are going to do acidity, basicity. Then after that, I'm going to bring one lecture on like full GOC questions, like PYQs related to GOC. Then next week, we are going to cover isomerism because that is also a very big topic, right? Okay, yes. But I'll complete isomerism in 2 lectures. Okay, I'll do that in 2 lectures. 2 lectures, 3 hours. In 6 hours, isomerism will be done. And after that, we'll start with hydrocarbons. Right? Okay. Okay then guys, bye-bye. I'll see you all in the next class. And what you need to do is, do your homework and write it down in the comment section. Till then, bye-bye. Take care. Bye-bye.